Hello everyone, today we're going to show you how to do composition of functions. So first we'll explain what function composition is and how we can write it correctly. And then we'll show you how to calculate the domain of composite functions. So what is function composition? It's basically when you have two functions that you're putting together to form a sort of chain. So in this example over here you have f of x equals 2x and g of x equals x squared. And if you want to make a composite out of that, you represent it in this way with this kind of open circle over here. And what this is going to mean is that the result of g of x is going to be sent through f of x. And it can also be represented in this way. And it can be very easily calculated by just taking your outside function and replacing x in your outside function with your inside function. So in this case, what you're going to get is this, which is just equal to 4x squared. So it is fairly simple, but the one thing to take into account is that if you were to switch these around, so you would have f of x being your outside function and then g of x being your inside function, you're actually going to get something different. So in this case, you're taking f of x and you're replacing this x over here with g of x. So you're going to get this, which is exactly the same as just writing this. And as you can see, these two are not the same. So you really have to pay attention to what is your inside function, what is your outside function. Second part is to know how to calculate the domain of a composite function, because as you will see shortly, it does not necessarily equal the domain of its individual components. So here's an example that's going to help you understand. We have fx and gx, and let's just write the composite function. As I explained before, what you have to do is you take the outside function, g of x, and wherever x appears, you just replace it with your f of x. So I'm just going to do that. Okay, so this is our composite function, and now we need to calculate the domain of it. This can be done in 3 separate steps. The first step is to look at the domain of the inside function, f of x. So the most obvious restriction here is that you have something over x, and we know that in this case, the denominator cannot be equal to 0. Since the denominator is a simple x, we just know that x cannot be equal to 0. So this value cannot be included in the domain, but all other numbers can. So we can just represent it like this. So the second step is to look at the domain of the composite function. And in this case, again, you have something over x's. So you have to make sure that the denominator is not equal to 0. In this case, you have 2 parts multiplying one another. So you know that this individually cannot be equal to 0, and this individually can also not be equal to 0. So we can just quickly calculate that by having these separate equations over here, plus 3. And for the second part, we do the same. So this tells us that our x cannot be equal to minus 1/3 or equal to a half, because that would involve the denominator being equal to 0, which just cannot happen. So here our domain is going to be every number except these values that you have calculated, which are these. The third step is just going to be adding these values that you got from calculating the domain of your composite function with the domain of your inside function, because obviously the inside function is what you're putting your values through, so you're also going to have to take that into consideration. So basically, which means that in the end, the domain of your composite function is just going to be all numbers except these 3. That's it.